All right, I'll start off by introducing our moderator, Dr. Tom Frazier. So Tom has been one of my bosses here at IDA for a number of years, but he left us for the hills of Virginia down in Nelson County, but every once in a while we bring him back. Tom's an economist, and turn it over to you, Tom, to introduce the folks on the panel.
Great. Thanks, Brian. Thanks so much. This panel has been assembled on the private side because of the characteristics that involve me. We have Jason, who's involved with weather. I follow the weather religiously. Ian, I'm sure he'll talk about digital assistants. I'm always on the phones talking to digital assistants and my populated with all the electronics in my house. And finally, Rob Cranston, who knows a lot about sports analytics, and that's all those three things are right in my wheelhouse. None of this other stuff matters so much. Let me take a few seconds to introduce our panelists, and then I'll tee it up with some questions to them. And all the panelists have suggested that we ought to leave more time. We have all this human capital sitting out there, this huge potential. Let's try to get them involved. So I think they want to encourage questions from the audience. First person I want to introduce is Jason Samenow. Now, a little personal aside on this. I have a daughter who's never, ever had any evidence, never shown any evidence of interest in any of my work over all the years. Zero. Not interested, always rolling her eyes. I'd say, oh my God, I ran this regression and I got an R-square. You can't believe it. She'd roll her eyes. Well, we were talking, and I live, as I said, in the hills of Virginia, West Virginia now, and I've said, I'm coming up, I'm going to be on a panel. And she goes, what a panel? What? I said, Jason Samenow is going to be there. She goes, Jason the weather capital? Oh my God! How do you know Jason Samenow? I said, well, he's going to be on the panel. She goes, well, oh my, can I come? And I go, no, you actually have to be good at math. Oh, would you have an R-square you'd like to share? No. So now by reflected glory, I am for the first time something in my daughter's life. Of course, we all know who Jason Samenow. Anybody that lives in this area know who Jason Samenow is. He's Washington Post weather editor. He founded the Capital Weather Gang .com in early 2000. This is sort of the first professional weather blogging on the internet. I believe something around 2008 got absorbed into Washington Post, and when he's led the Capital Weather Gang there ever since. He's attended the University of Virginia, where he earned a degree in environmental science, focusing on atmospheric science. And he went on to earn a master's degree in atmospheric science from UW-Madison. There you go. Oh, you Badgers are the same. Not good at math, but not much personality. From 2000 to 2010, he worked as a climate change science analyst at the federal government, monitoring, analyzing, and communicating science of climate change. He's past chairman of DC chapter of American Meteorological Society and the Weather Society Integrated Studies Fellow. He also holds the Weather Association Digital Seal Approval, and I believe he is, you worked with Bob Bryan, my hero, well, my hero when I was growing up here watching the weather, Bob Bryan. Our other panelist is Ian Beaver. These digital assistants have become so ubiquitous. Juniper Research reports that by 2023, 1/4 of the population will be using digital voice assistants daily, and by the end of the year, they're estimating the installed base for smart speakers is expected to be over 200 million units. And the biggest challenge these digital assistants is people like me, who try to interact with these things and try to get, how do they understand what I'm saying? I got to believe there's all these issues associated with interpreting and trying to understand what the human is trying to say. Well, detecting and resolving misunderstandings between human and machines is a specialty of Ian. He's the chief scientist at Verint, Intelligence Self-Service. He received his PhD in computer science from the University of New Mexico and holds a BS in MS in computer science from Eastern Washington. And I'm sure he'll talk about what I think probably a lot of people in this audience, I know here at IDO, folks who do a lot of work on recruiting and retention of the services, know his chat box, the Sergeant Star, the virtual recruiter. So I'm sure there'll be people here to talk a little bit about that. I just noticed in yesterday's Wall Street Journal lead article is the Army missing its recruiting targets and talking about how they could better what they need to do, and they're in quite a pickle, and maybe Ian will have some insights into that. Finally, to my other passion in life is sports. Although Rob has my dream job. He gets to talk about gradient boosting algorithms and how they apply to the St. Louis Cardinals or the Chicago Cubs or professional lacrosse. He's the Chief Operating Officer at CANA Advisors. CANA is a veteran-owned and woman-owned small business, and I think in headquarters out in Gainesville. He founded CANA Advisors in 2008. He has 20 years of experience in operations and logistics systems management, business strategy, and product demand planning. He's a former U.S. Marine Corps officer. He has a Master of Science in Finance from Johns Hopkins University and a Bachelor of Science in Political Science from the University of Colorado. So we may have dueling. One of the things he also does is, I think, on brackets and those sorts of things. So maybe we could have a little, we got a little trash talking going on between he and Laura. Who knows about that? So let me start off with just tee up a few questions and see how, and then to get things going, and then we'll invite the audience to participate. Let me first ask Jason, what are the key elements of weather forecasts that make it useful to these? I mean, you talk about highly diverse audiences. You've got to speak to these scientists, or all the way down to people like me who just want to know, is it going to rain tomorrow? So what are the key elements that makes forecasting useful?
Sure. Okay. First of all, thank you for the very nice introduction. It's a pleasure to be here, and it's great to speak to some folks I normally don't speak with, and this community is one which is a great opportunity for me to broaden my horizons a little bit. So, good morning. So in terms of forecast usefulness, I think there are several key elements, and I would say timing, getting the timing right for people. I would say location specifics. Where are the weather hazards that matter going to be impacting people? The intensity of the event, that is, how severe is it going to be? And then finally, the other important aspect is communicating uncertainty, and I think that's really critical and something we put a real emphasis on. I think sort of getting back to timing, when you're talking about a hazardous weather situation, people want to know, okay, when is this going to start and finish? I mean, those are key elements, and so we put a real emphasis on that in terms of trying to give people, you can seldom nail it down to 10 or 15 minutes. You give people a range as to when you think an event will start and stop. The onset time is important for preparation, so people can obviously get, be where they need to be. If it's a snowstorm approaching, if they're at work and they know that the snow is going to be starting at 4 o'clock, they're leaving home by 2 o'clock, so they're not getting stuck in it. The onset time is really important from that perspective, and just in terms of if it's a more severe event like a hurricane, making sure all of your preparations are completed, such as boarding up your home, evacuating, getting your go kit ready so that you have all your supplies that you need to weather the storm. So I would say that in terms of onset time being critical. And then the all clear. People want to know when they can obviously go back outside. If it's a thunderstorm, they want to know when they can return home if they're evacuating a hurricane. So the finishing time, that's of course very important. And I would say a third time people really care about is, what is it going to be the worst? Okay, when is this going to be a particularly dangerous situation? When will this be most intense? So those are the things we focus on in terms of timing. In terms of location, everyone wants to know what's going to happen in where they live. So the most common question we get during snowstorms: how much for Reston? How much for Herndon? How much for La Plata? And so everyone wants to know how much in their backyard. And so we produce maps, and sometimes people don't know how to read a map, so you have to assist them with that. Location specifics are really, really important. And again, obviously, you need to be able to convey to people how severe the hazard you're talking about is going to be. So you use data which is fed through models to try to isolate that and give people a sense as to how big a deal this is. You can use past storms as analogs so that there's something in their recent memory to remind them of what might be coming with hurricanes. We might say, well, this storm is most similar to Hurricane Isabel from 2003 or something like that to give people a sense. But it's also important in those situations because no two storms are exactly alike, that you also in addition to mentioning the similarities, you also include the differences. Finally, I would say communicating uncertainty is key. And of course, weather is an imperfect science, weather forecasting is. And what we try to do, especially for significant events, is give ranges and present scenarios. So for snowstorms, what we do is we present what we call boom and bust scenarios. So we'll give our most likely forecast because people say it's a cop-out if we just sort of give these huge ranges and say, oh, it could be anywhere between 0 and 15 inches. I mean, that's often true here in Washington because we're often right on the rain-snow line, and conditions can vary markedly over small distances. But what we do is we give these boom and bust scenarios. So we'll tell people what's most likely, but then we'll say, okay, this is the possibility or the percent chance that it will be less than what we think is most likely, and that's the bust scenario. And that's the scenario that school kids hate because that means they're going to school when we have snow in the forecast. And then there's the boom scenario, which is what the snow lovers really love, and that's the chance that the snowfall will be more than we're predicting, and what we think the likelihood is of that. And so we present this on a map. We also indicate our confidence. Some weather situations are more predictable than others. In some situations, the models all agree that we look at. Other situations, there's a big spread in the model output, so we'll try to convey confidence, from low to high to give people that sense of how predictable the situation is. The other thing we do in terms of communicating uncertainty, we do this a lot with hurricanes and winter storms as well, is we'll sort of present a range of scenarios. We'll say, okay, the storm tracks this way, this is what's going to happen. If it tracks this way, takes a route more to the west, or, this is what we think will happen. So we sort of lay it out so people understand sort of the full range of possibilities so they can be better prepared to make decisions.
Yes. Can you tell us this? Of course, now we all hear about the cone of uncertainty. Is that a National Weather Service term of art? I mean, are there status? And sort of, could you explain about sort of how they come up with it? And do you think that is a good tool to convey uncertainty?
Sure, yeah. So the cone of uncertainty, yes, that's an official product of the National Hurricane Center. They've been using it for years, maybe decades now, actually. And it's their best estimate of where the storm is most likely to track. Of course, the cone expands as you go further out in time because our forecasts are worse. There's larger errors in the forecasts at 72 hours compared to 24 hours. So, and the width of the cone is actually based on what the historical forecast error is. So, I don't have the numbers in front of me. So say like the forecast error at 24 hours, maybe it's 30 miles, and at 72 hours, maybe it's 90 miles. So that cone expands based on the average error at specific times, based on historical data. Now, what can be misleading about that is that, the historical data, that's just an average of all storms, and every storm has a different amount of predictability. So in some cases, the cone might exaggerate the amount of uncertainty there is, because if all the models agree that at 72 hours it's going to be in a certain position and the historical track error is 100 miles, then in that case, the cone's exaggerating the uncertainty. But then there are cases where the models are all over the place at 72 hours, and the historical averages actually are understating the amount of uncertainty. And so sometimes I think in my opinion, they should, and I think the Hurricane Center is actually working on this, and in terms of how they evolve the cone, I think the cone should, instead of being a reflection of the historical average error, it should be a reflection of it should be a reflection of the model uncertainty, because those are our best tools right now for communicating the forecasts. And so if the models are all over the place at 72 hours, you should have a much wider cone, whereas if the models are in lockstep and all agree, then the cone should be much narrower, because that would give decision makers a much better idea of what the actual uncertainty is rather than the historical
That's
uncertainty.
interesting, thanks. Ian, let me drag you into this. Over the years, I've heard, of course, of Sergeant Star and what that does, but I've also heard about the interesting sort of counterfactual sort of outcomes that have been result from that is sort of surprisingly fine. Could you, for the uninitiated, can you tell us about the Sergeant Star project, and what are some of the interesting and counterfactual things that have come out of that?
Sure. Thanks again for putting this on and the introduction. I'm kind of curious, has anybody talked to Sergeant Star in here or heard of? Okay. Have you talked to a virtual assistant like Siri or Alexa? Okay. Well, for one, get used to it, because as he was saying, we really are seeing a trajectory where more and more of our daily tasks are going to get really driven through conversational interfaces like that. As we see things like smart cars, self-driving cars coming down the pipe, how are you going to communicate with it? You're going to talk to it. You're going to tell it where you want to go. You have to have these sort of natural language understanding built into these things. And so Sergeant Star is what we would consider to be a virtual assistant or a chatbot or a conversational interface. And he's set up as a virtual recruiter. He lives on Army's website. He's also integrated into Facebook Messenger, and he's got dedicated mobile apps and things that you can talk to him over. And he's really about helping people understand the Army, what Army life is like, what the basic things about what it's like to be deployed, really answering questions for both people that are curious and also their families and things. We started development of STAR back in 2004. We started talking to Recruiting Command about building this virtual recruiter that could take over. Well, it was partly to do with cost cutting, but also because they were running live chat on their website at the time with about 55 personnel that were sitting there. Just they were recruiters, and they were answering people's questions about the Army. And they were looking how to scale that and cut costs at the same time. And so they sort of had this idea of a virtual recruiter, and through negotiations and everything and implementation, it went live in 2006. And it currently talks to about 900 unique people per day, which isn't bad for a single recruiter. He understands about 1,100 different user intentions, which is really like units of understanding of responding to people. And over the years, as STAR's knowledge has grown and we've made improvements to it, the Army noticed that only about 3% of conversations that people were talking to STAR were actually ever escalating to live personnel. So they ended up just shutting down live chat altogether on their website, and those people were moved over to email and phone support and things. So STAR is the only conversational interface on their website now. And another thing was the Army was, and still is, they're very interested in reaching youth. And what are the technologies that young people are using, and how do we get to there? And for other examples, they've been involved in video games a lot. So they created America's Army, and they do gaming competitions and things to try and get young people interested in Army life and signing up. But I want to kind of set the stage a little bit on this, because if you think about 2004, this was 7 years before Siri went live, and back then chatbots or virtual assistants were not well known. There wasn't an Alexa, there wasn't any of these things. And so most people didn't understand them. The people that had heard of a chatbot either thought they were kind of a fad or a gimmick, or they thought they were like the precursor to Skynet and were going to take over the world. So we had to do a lot of uphill battles in sales and things to try and get people to understand the real value of a virtual assistant and how they can be leveraged. And so the Army really had a novel idea back then to virtualize its recruiting services, and it's still paying off for them today. As I mentioned, they've been able to save basically the job of 55 people with this single piece of software.
How's the results of this? When the feedback, does that change their processes and websites and stuff? Does these results that they get from your chat box, the things that feedback, does it result in sort of, how does it manifest itself in how the Army does business?
Yeah, so basically, Sergeant Starr's conversations are used multiple ways within the Army. As I mentioned before, they're very interested in what's on the top of mind of potential recruits. They're looking at what are their concerns and what are the things that young people are, what are their views of the Army. And so we do a lot of analysis on these conversations that come through on behalf of the Army and try to find out what are the trending topics, what are the concerns people have. And that's resulted in a lot of changes. For one, when STAR launched at the time, the Army's website was really about we're the Army, we're awesome, you should join us. And what they started seeing was a lot of these conversations coming in. People just had really just practical day-to-day questions, like how am I supposed to pay my bills when I'm deployed, or are there stalls in the bathroom, or do I really have to cut my hair? These types of just total practical questions people had about Army life. So the Army went around and collected a lot of these and basically redesigned their website, and they added a video Q&A section where they have currently over 400 of these questions being answered by Army personnel on video, and you can search them and go through that. So that's one way that the Army has used these conversations. The other thing was really looking at unexpected things. So a lot of people, I don't know if it's a lot, but we were seeing a lot of veterans and even deployed military talking to Sergeant Starr about things that were not really what he was intended for. So, I mean, he's a virtual recruiter, so he's about getting people in the Army. But veterans and even deployed personnel were asking him questions about resources for PTSD, insomnia, battlefield fatigue, things that were not really what you would expect people would talk to a recruiter about. So we started really digging into these conversations, trying to figure out sort of the motives. And we found, to the best of our abilities, that people are very concerned about image, and they're somewhat ashamed to go talk to a human about experiencing these mental or physical difficulties. And so Sergeant Starr is understanding that it's a bot, is not going to judge them. He's not going to react. He's not going to put them on leave or somehow cause repercussions to their life. And so they feel it's a safe place to ask for these sort of resources. And so what we were able to do was collect a lot of these and send it off to the Defense Health Agency and say, hey, you guys, there's people that really are trying to self-serve in this area, and they want help and they want resources, but they're not at a place where they want to go talk to a doctor yet or something. So can you please provide more self-service in these areas for these both veterans and deployed people out there? And a third area where this data is really used is policymakers look at what are the sorts of things people feel about the Army based on what are they talking about, and is there possible changes in policy that should be made because of this. And also, when they go to change policy, they go back and they look at the conversational history before the policy was in place and then after the policy was in place, and they see, did the policy have the desired effect that we were after? So all of this is really made possible because it's a natural language interface where people can say whatever they want. It's not like an IVR tree where you have to push 1, push 5, or like just a static website where people can get information but they can't give you any information. And so the fact that people are just free to talk about whatever they want provides all of this data that then can be analyzed to produce these actionable insights for the Army itself to better cater its website and its services and even its image and policies towards the current generation.
That's fantastic. A very interesting application. Hits right on the nose, our topic here about usable information. I want to come back to something else you said in a sec. Rob, I think most of you, we've chatted, and I think most of your customers are the Marine Corps or the Navy are big ones. I think you do work for the Treasury and some other non-DoD ones. I want to talk a little bit about your work for the Navy and the Marine Corps, obviously, here in the DoD setting. You just talk us a little bit about what are some of the things you do now, and then I got a couple follow-ups I'd like to ask you.
Yeah, super. And again, thank Tom and Brian for having me here and being part of the crew here. I would say that data is the new bacon. And it depends on how crisp that bacon was previous to when data was introduced. But yeah, we've had an opportunity at CANA to provide services, both federal and commercial. We've got a portfolio of data analysts, ops research, and data scientists. Got some developers on staff. And what's been really interesting is this dynamic of interpretation of and what is this institutional change of how data within the CIO office and now the CDOs coming online is really creating an environment where there's a spin. There's a spin of getting to actualized data and data that's going to really create this environment of change. But there's got to be proof of pilots and confidence in that. So we've been really fortunate in our Navy Marine Corps partnership and work up in the world of maintenance force flow estimators that we've provided within the environment of pre-position assets. So within that, we've been able to use different type of tools, different really progressive tools in analytics as software. R series, R Shiny, Python. We've really been able to teach our young analysts and bringing them forward with what are solutions that really create a learning and development environment with our clients. So with that, yeah, I know we want to talk sport. I'm a Cardinals guy. I came from St. Louis originally, and so I'm split between the Nats and the Cards, but.
Yeah, right.
Tom, throw the softball out.
Right.
Question.
That's it. And have you done some work for the Cubs also?
No. So what we've done is we've done some analysis. So on the sports side, it's really on the commercial. So on our commercial practice, we've worked across manufacturing, retail. We've worked in the oil, gas communities, and a lot of those are related to logistics transportation requirements. So building transportation models using different types of telematics, being able to in previous and I think Laura, you were talking through some of those specifics of routing. So within that commercial space, we provide some of those models and examples in the federal. Yeah.
Let me come back to Jason, because you touched on something, talking about the models, and how do you use data analytics to sort of reconcile? I always hear about there's the European model, and there's all, but I take it there's a whole bunch of models, and I take it you synthesize these things, and how do you reconcile them? Do you weight them? Do you have some sort of an algorithm to weight them? to weight various forecasts, those sorts of things?
Yeah, sure. So, yeah, you're absolutely right. There are a whole set of models that we look at, and there is the European model, which is run from out of the European Center for Medium Range Weather Forecasting. I think that's in Reading, in the UK. And there's the American model, the GFS model, the Global Forecasting System model, which is run here by NOAA and the National Weather Service. The Canadians have a model which is pretty good. There's also a UK, in addition to the European model, there's a UK, and there's another model in the UK called the UK Met model, which is very good. So there are actually ways for us to objectively evaluate how well these models are doing, and the output that the models put out there, there are programs out there which evaluate their skill, how well they're performing. And the European model has been historically, for at least the last 10 to 20 years, the highest performing model, meaning that on average, it's the most skillful, meaning it's the most accurate in general, but it's not that most accurate in every situation and with every storm. I think that's important to emphasize. And so the American model, sometimes beats it. But if I'm short on time and I only have one, and I can only look at one, I'll look at the European. And actually, the number 2 ranked model is the UK Met. So the 2 best models in the world are actually run across the pond. We rank 3rd, the Canadians is in 4th. The US government's putting a lot of money into trying to improve our global model. It's kind of an arms race. The Europeans are continuing to pump resources into their models as well. These are run on supercomputers, so these are like highly sophisticated, high performance computing. They're doing trillions of calculations, over very short periods of time. So very numerically rigorous models. And so what we do as forecasters is we look across the universe of models, and we have to understand what their strengths and weaknesses are, what their biases are. We have to understand, in a given situation, which model makes most sense. Now, of course, our job is easiest when they all agree, and that's sometimes the case, but they don't always. And some of the more challenging forecasts is like when you're right along the edge of a storm. So where are the significant impacts going to start and stop? And so that's when communicating uncertainty is really important. The other thing we have, another tool in the toolbox, is that these models now have what are called ensemble systems. In other words, you take the main run of the model, then you tweak some of the initial conditions feeding into the model, and you run it a bunch of different times just with slight tweaks to those initial conditions. So you can have a family, so within a given modeling system, you can have one main model, which is run at the highest resolution, but then you can have an additional 20, and with the European system, their ensemble system is actually 50 alternative simulations you can look at. So you can have the main simulation, but then you have 50 alternatives you can look at with slight tweaks to the information going into them. And so that gives you a sense of what the uncertainty is. So we not only look at the main high resolution runs of these models, we look at these larger ensemble systems to get a sense of the uncertainty and to better understand the range of possible outcomes, if that makes sense. So
Yes.
we have a lot, but the bottom line is we have a lot of tools in our toolbox now, but even with that, we still have very challenging forecasts. And I think, numerical weather prediction and weather forecasting in general has made a lot of strides in the last few decades. We basically gained a day of skill per decade. So, we can go out with confidence. We've been able to go out a day longer in terms of being able to produce an accurate forecast each decade. So, in the 1980s, maybe, a 2-day forecast is now now a 4-day forecast is as accurate as a 2-day forecast was a couple decades ago, in other words, if that makes sense. So we're making progress. The question is, how much better can we get? Right now, in terms of an accurate weather forecast, 24 hours is very good, 90, 95%. Out to 72 hours, you're in the 70 to 80% range. And you have some skill. In other words, you're going to do better than just you know, taking a guess out to about 7, 8, 9 days. And then once you get beyond 7 or 8, 9 days, you're really kind of into no man's land where basically historical averages are going to be just as good as what your forecast is.
Oh, very interesting. Before we started today, I caught up with a colleague from many years ago. Our career paths have taken different projections. Mine sort of like this, and now she is a very, very big deal. And we were talking, and I won't name her name, Christy. But we were talking about, and I think we're old school, and we were talking about, well, I think a question was, I have all these different databases, and isn't it true that resolving the data integration problem is a necessary condition before I can even think about all these highfalutin analytical sort of tools and these sorts of things? And that's really a big problem. Ian, is that what you find from your customers? I mean, they say, man, I am blown away how clever you guys are with data and those sorts of things, but man, I've got such basic problems before I even think about that. Is that something that comes up in your work?
Yeah, our job is a lot of times to educate our own customers on their own data. And so what happens when we get, say, a new customer that comes, and we work with both private and public sector. We have a lot of government clients, and we have a lot of private corporations and things. And we go in and we first try to identify what are the areas that are ripe for automation. So what are the things that your customer base or constituents are contacting you about, and what of those is the low-hanging fruit that we can automate quickly and easily? And so the first thing we have to do is get some form of if they have emails or if they already have live chat, or if they've got a call center and we can get transcriptions, or in worst case, we scrape their website. What data do you have that demonstrates how people interact with your agency or interact with your company? And we take that information and we do a bunch of analysis on it, and we try and figure out, like, what are the common threads or topics or contact points that are coming up. And of those, how complex are they? Are you trying to book a flight, or are you trying to do some really complicated task like drive a car? Or are you trying to just like reset your password or something like that? And so we kind of rank them by how easy to automate these tasks would be and how common those tasks. And taking the intersection of those is really where we start. And then once we get the easy things out of the way, we start looking into how else we can expand the conversational interface to cover maybe harder cases or cases that require a lot of complex interaction with the users, like back and forth, where are you flying to, where are you flying from, like how many people are you taking, those types of goal-oriented dialogues. And so having that data up front is really helpful for us. If you don't, there's some things we can do as well. We can stand up data collection interfaces where it looks like a chatbot or something, but it's really just like, how can I help you? People tell us, we're like, thanks. Let's direct you to something else, and that gives us the data, at least to bootstrap, that we can start figuring out what are the contact points for your customers.
Interesting. Well, I promise I'll only ask one more question, then I'll turn it over to you guys. I want to ask Rob, we had a discussion before this, and we're chatting, and one of my priors was that one of the reasons we might not see the adoption of data analytics within the Department of Defense and the federal government is there's a lot of these institutional barriers. We all know about all the FARs and all the regulations about getting people on contract, and things move so fast. And I wanted to ask Rob, as somebody who works in both sectors, and we had and I think he has an interesting story to tell about how sometimes dealing with the government, with DOD, is actually easier than it is with the private industry. Could you talk a little bit about the IPA issues and stuff?
Well, this goes back to IP rights and really understand contractually on the federal side, contractually bringing in outside resources, and to the acquisition structure, which is framed in a very rigorous way on the federal side, which is important, is interesting. On the commercial sector side, there's actually a tremendous amount of rigor, making sure that whatever is produced on the IP or in those type of scopes of work, that that information is protected. Examples in sports teams want to have, and they're competitive, right? I mean, they have to have information that's shared across their departments of business side and player and development side, or what is the coaching side. And that information they want to keep collectively organic. So any type of outside resource, most of the time, you'll find that contracted support or support that's a long-term effort is going to be exclusive. And it has to be, because they don't want that information going out to other teams, et cetera. On the federal side, and as you all have been around decades and decades, importantly is to make sure that, for example, web-based hosting and what is right now, whether those are app developments, those resources that are analytics wraps itself around in some cases, to make sure that that's articulated correctly, and that the CIO office has some great literature and information, as we know, that are guiding documents. But importantly is that, and to the question is that, yeah, the rigor on the commercial side is almost even more so in developing out the scope and making sure there's locked tight in terms of legal terms is even more so.
Interesting. I wouldn't have thought that. Turn it over to questions, and if you could wait till Brian or somebody brings the microphone to you, we'll get it to Mike here in a sec.
Hi, thank you. So I'm Mike Dominguez. I'm here at IDA. It's been a long time since I was a technical analyst, so I'm more familiar at the policy and management levels. And I want to explore this data is the new bacon. Because what I've been hearing for some time now, not just at this forum, right, is that you may have broken the rule that I learned about, computer analysis, computer-supported analysis, which is that garbage in, garbage out, right? So, so if you imagine an environment, which I think characterizes the DoD, where lots of data that are used to manage in the department were developed locally for local purposes by local commanders and leaders, and the structure, the taxonomy, for that data is not stable over time. So it changes as local needs change, et cetera. And what I'm hearing from Bob Daigle, for example, is if I scoop all that stuff up and dump it into a data lake, instead of pollution, we get, this instant clarity, right? But today, my experience here observing the technical people at IDA is when they get a problem, they take 8 months of a one-year study to try and turn the garbage that came to us labeled data into data that can actually be fed into models that can answer a person's question, right? So, again, there's a lot of buzz that people at the policy level, I think, are being confused by, that, oh, this is now magically all erased by the data lake easy button, right? Can you address that, please?
Yeah,
Start with Rob.
Yeah. It's a great question. So I get nervous about when you start talking about data, how deep the lake is, and understanding where an information hosting of data, where that is stored. But going back, and Bob had a question from an analyst earlier, is really important. I was talking to a couple of folks about this, and that's ensuring that the analyst is armed with the right information set and confident enough, knowing that they can go in and break down barriers. And barriers being barriers of what is traditional data sets that are put into an Excel spreadsheet, and I have my pivot table, and boy, I'm going to keep this here. And that's a comfort thing. So there's this cultural shift of making sure that that data information set is being looked at from a higher level. And boy, that's going to be its ownership, that ownership of that data. That data, once it's provided into a larger data set from analysis, that has a huge impact on what becomes maybe change in policy or the way that we use and sanitize data. But sanitized data and realize what is real data, that's a day-to-day type of function and activity. You can't just sit over, we've done a studies and analysis and sit here. It has to be actualized.
Mike, did you ever, when you were in your previous role, Mike here at IDA ran a bunch of scientists, but in his previous roles in the Department of Defense, did you ever have like a killer data analytics that came to you or that solved some problem for you big time? I didn't mean to put you on the spot, but
I was a heavy user of analysis.
right. I mean, public PNR. I mean, the
Yeah,
DoD.
Well, yeah, I mean, one study that I think really moved the needle was done by CNA, where we were trying to recover from the Walter Reed debacle and had major focus on the wounded warrior problem.
Right.
We started looking at caregivers, right? When you have grievously wounded people, coming back from the theater, not only do we have in our institutions in DOD and VA take care of them a long time, but typically a family member steps out of their prior life and becomes a full-time caregiver. It was an analysis by CNA that really identified the characteristics of those people so that we could understand what kind of policies to deploy to support people who at that time of their life had stopped living their life so that they could become a full-time caregiver for somebody else.
Very interesting. Cool. Thanks. I didn't mean to put you on the spot. Mike. Any other? Ian.
I just want to comment on that really quickly. So garbage in, garbage out is, I would say, probably even more critical today than it used to be with the age of machine learning. And working in that space and with machine learning tools all day, we really have to be careful about bias that's being introduced by the data and how it was collected and what it means. And there's all kinds of other quotes you can say. You can say like, if you torture the data long enough, it'll confess to anything. Or George E.P. Fox said that all models are wrong, but some are useful, and that's very true. And so just because you put everything in one place, you haven't done away with that data curation. And there is actually a lot of research happening nowadays into interpretability, and because a model made a prediction, why did it make that prediction? What features was it specifically relying on to make that prediction, and where did those features come from? And being able to tag a lot of these large-scale, data lake solutions have now built in these governance capabilities so that you can actually see what pieces of information were used to build this model, and that's audited. Things like GDPR have played a role in that, because if I'm going to use somebody's data to build a model and somebody says like, well, I want my data removed from your system, we have to be able to say, is that data influencing this model? And how do we get back to that original form and remove that person's information without disrupting the model? And so it hasn't gone away. Salespeople would maybe like you to believe that it has, but it's just changed. So instead of a bunch of analysts independently doing that work, it's more centralized, and that work is done more openly. And now there's a lot of tools that help you do that work and visualize and audit that governance of the data in a centralized place. So that's
Very interesting. Yeah.
Yeah, I can make one.
Sure,
small
sure.
additional point. I recently reported on a company based in Boston called Climacell, and they are building their own weather models by incorporating data that they call the weather of things. In other words, your smartphones collect pressure data, and so they're potentially millions upon millions of data points that people are carrying around with them all the time, which can be integrated into these models. There are drones, there are autonomous vehicles, there are cell phone towers. There are all sorts of various information platforms out there which can potentially derive weather data. And this company is taking that data, all these different data sources, and they're trying to beat the models I just talked to you all about, the European model, the American model, which are run by large governments. There are now sort of these fledgling technology companies which are trying to bring in these new sources of data and try to beat the government models. And so far, there are some promising signs that they are able to, in certain applications, improve upon what the government's doing. So yes, they have to overcome some of these data quality issues. You know, every new observing platform you have, there's going to be biases in the data. There are going to be irregularities that you have to deal with. But that's what some of these companies are doing, but there is potential there.
Wow, interesting. David?
I think this is primarily for Ian. This is on the question of learning by doing and feedback with these kind of analytic systems. And I'm curious about Sergeant Starr, whether the data enabled you to look at the effectiveness of that in terms of the satisfaction of potential recruits or decisions of potential recruits relative to when there was a live person on the phone. And also, are you able to look at whether the system has gotten better over time in terms of the customer experience, if you will?
Yeah, so I guess the ultimate key performance indicator for the Army is how many people sign up for the Army, and that's difficult to pin down to Sergeant Starr. But one feedback mechanism that we can incorporate is from the other human recruiters. And so some of the feedback we've gotten from them is the fact that when people come into a recruitment office or call them on the phone and they have previously talked to Sergeant Starr, they have very few remaining questions. They're mostly ready to just sign up. They use Sergeant Starr to sort of vet out all the difficult things, you know, maybe more of the personal questions, things that they wouldn't either feel comfortable with asking a person live or just even like the general stuff has been taken care of, and maybe they just have one or two questions around deployment or when do I start basic or those sorts of things. So the feedback from the recruiters is that when people talk to Starr, basically they've gotten all the hard stuff out of the way and they're just ready to go. So as far as analytics around volume of people registering for the Army that talked to Starr and didn't, I don't think there's a good way to get at that information because Sergeant Starr is anonymous. So we don't know who's talking to him. We can't say that like, oh, you know, John Doe in Minnesota is talking to Sergeant Starr right now and he signed up for the Army. We don't know who they are, and that's by design. The Army is very interested in maintaining anonymity when having these discussions for privacy reasons and other things. But so that, you know, unfortunately, that metric isn't really possible. You know, you can look at recruitment over time and success rates of people signing up for the military, but it's really hard to tie that to Sergeant Starr directly. I don't know if that answers your question, but.
We have time for a couple more. Did you have a question, Colonel, or any other
I
questions?
want to jump in on a question nobody else has. So, Rob, you mentioned in one of our earlier conversations that you do some work for the military, you do some work on professional lacrosse. Are there any synergies between those two domains?
Yeah, it's really interesting. So when you look at, there are, and Ryan, what's interesting when you're looking at human performance data and really how correlation of an 18, 24-year-old that's unable to hit a slider between the 7th and 9th innings in Colorado. And why is that? And some of that dynamic of understanding their thinking, going back to how they're training, how they're going into their own type of discovery, if you will, of how to be a better player, but how to also hit a slider. correlates to an 18, 24-year-old that's making quick decisions on the battlefield. And how are those decision-making from training as a result, and what are those results, are very similar in the way you get stress levels, how those are managed, and how those are built back into what becomes training and execution of mission.
Over here is Greg.
My name is Jennifer Bewley. I work for IDA. I'm actually also a meteorologist. So I agree with everything that Jason said so far.
Excellent.
But I do have a question. Do you think that there is like a theoretical maximum on how good the forecast can get? Are we going to hit like a limit on like maybe 14 days? Or is there some theoretical, like even if you had all of the data perfect for the initial conditions, that we just won't get to a certain point? And then this kind of also for the rest of the panel, is there ever too much data? Or could you always use more?
It's interesting you asked that question. There was a paper which came out on Science, I think about a year ago. And I think it was from researchers at Penn State who are a lot smarter than I am, who have PhDs in meteorology and who do this sort of numerical modeling. And I think they came up with about 18 days, or around 18 days is kind of where the theoretical maximum might be. Of course, there's this whole notion of chaos theory, which is, beyond a certain point, like you just, small changes, in one particular place can sort of propagate and expand and grow so large that, it's going to be impossible to get details right, farther and farther out in time. And so, so I think, who knows if 18 days is right. That's what their study sort of came out with, based on, what computers might be able to do and our understanding of the systems and how they work. But that's, how, whether that's, that finding stands, we'll have to see.
It can be too rich, too thin, and have too much data.
I would agree with what Laura was saying earlier, in that honestly the quality of your data is much more important than the quantity. You can make much better decisions with a smaller volume of data if it reflects accurately the environment the model is going to be deployed in. One of the biggest things we see in machine learning is that people use all these publicly available data sets to train their models, and then when they go to deploy them into a specialized environment, it falls on its face. And so just because I used some publicly, famous data set, for example, going to like conversational data, if I use like movie reviews, say, or Amazon reviews or something, because it's a Reddit, it's like free and there's tons of it, and I can train, models to understand people. And then I go and I try and build, a model that is supposed to interact with people in a healthcare space. There's so much terminology that is missing or has special meaning in that particular domain that is not in, Amazon reviews or Reddit or something like that. And so I would be much better off with a small sample from healthcare data that is exactly in the domain I am trying to model and deploy a model in, than just having all the data in the world. Because what that happens is the special things that you're interested in become much less frequent in that data set. And so the probabilities and things of getting it right when those special terminologies are used are decreased. And so quality is much better than quantity.
All right. Yeah, I was just saying, time-wise?
Yeah, we're good. Go for it.
No, I was going to say, I concur, but from the business side, I will tell you this, that, and especially at the executive level, the amount of working cap that goes into evaluating data right now is really tricky. Really tricky. I mean, from making sure that working and being solvent is, whether it's a small middle market business that's utilizing data, I would say that right now, employing capital to work data sets can only go for so long. And so there's where amount of data, and is there endless data? There's a cap.
Yeah, I mean, I would just add, that, we are tracking Hurricane Dorian, there were some models out there, which were outliers, and they weren't good models, but people were paying attention to them. They were, almost the best models out there, and the consensus of the models was that, the center of Dorian was way east of the Florida coast, and but there are people posting to Twitter these alternative models, including one from experimental model from IBM called Blue Thunder, which was showing the storm turning over the Florida Peninsula, and that was distracting people and causing people to kind of second guess what the other models were saying. So unless you have confidence, unless you know the data is good, just because you have an additional model, you have an additional data set, it can be a distraction, and it can actually impact decisions, and it can take up people's time. So I think that's something we have to keep an eye on.
All right, I'd like to thank the speakers again.
Let's hear it for the moderator. Oh, sorry.
I also want to add that Ian came from Washington State, so he sat on an airplane a long time to come join us today.
Oh, awesome. Thanks, Ian.
But one other thing I like to ask folks to do is, my boss told me that it's kind of ironic that we have a data analytics conference and I don't collect any data on the conference. So what I like to ask is, if you could just shoot me an email that there's a particular talk you enjoyed, that would be fantastic. Also for the folks on the live stream, if you could shoot us an email, say, hey, this live stream was helpful, we couldn't be there in person, and also give some feedback about what you thought about the conference. Just a short email is great. And I'll put up contact info. I think a lot of you have my email. I've been pestering you, so thank you.